Akila. I'm Nura Atika.
I'm Adia Zafira.
I'm Warna Suha.
I'm Muhammad Kuzaimi.
So, we are going to present about FTIR. So, let's watch it. Bye.
Hey guys, I will be talking about FTIR. Fourier transform infrared spectroscopy is a technique which is used to obtain an infrared spectrum of an absorption, emission, photoconductivity or Raman scattering of a solid, liquid and gas. And FTIR simultaneously spectroscopy simultaneously collects spectral data in a wide spectral range. The term Fourier transform infrared spectroscopy originates from the fact that a Fourier transform, a mathematical process, is required to convert the raw data into the actual spectrum. FTIR is the preferred method of infrared spectroscopy. In infrared spectroscopy, IR radiation is passed through a sample. Some of the infrared radiation is absorbed by the sample and some of it is passed through. The resulting spectrum represents the molecular absorption and transmission, creating a molecular fingerprint of the sample. Like a fingerprint, no two unique molecular structures produce the same infrared spectrum. This makes infrared spectroscopy useful for several types of analysis. It can identify unknown materials. It can determine the quality of consistency of sample. It can determine the amount of components in a mixture. FTIR spectrometry was developed in order to overcome the limitations encountered with dispersive instruments. The main difficulty was the slow scanning process. A method for measuring all of the infrared frequencies simultaneously rather than individually was needed. A solution was developed which employed a very simple optical device called an interferometer. The interferometer produces a unique type of signal which has all of the infrared frequencies encoded into it. The signal can be measured very quickly, usually on the order of 1 second or so. Thus, the time element per sample is reduced to a matter of a few seconds rather than several minutes.
Hi, Assalamualaikum. I'm very sure you guys already understand a little about FTIR after watching the previous slide. So, I'm going to explain about the component of FTIR spectrometer. Okay, a common FTIR consists of source, interferometer, sample compartment, detector, amplifier, AD converter, and computer. So, I'm also prepared a slide to make you guys more understand about what I'm going to talk. So, don't skip the slide and watch more for video. So, bye!
The source generates radiation which passes the sample through the interferometer and reaches the detector. Then, the signal is amplified and converted to digital signal by the amplifier and analog to the digital converter respectively. Eventually, the signal is transferred to a computer in which Fourier transform is carried out. Okay, this is the block diagram of an FTIR spectrometer. The goal of any absorption spectroscopy is to measure how well a sample absorbs light at each wavelength. The most straightforward way to do this is to shine a monochromatic light beam at a sample. Measure how much of the light is absorbed and repeat for each different wavelength. FTIR technique shines a beam containing many frequencies of light at once and measure how much of that beam is absorbed by the sample. The beam described above is generated by starting with a broadband-like source, one containing the full spectrum of wavelength to be measured. The major difference between an FTIR spectrometer and a dispersive IR spectrometer is the Michelson interferometer. Michelson interferometer is used to split one beam of light into two so that the paths of the two beams are different. Then the Michelson interferometer recombines the two beams and conducts them into the detector, where the difference of the intensity of these two beams are measured as a function of the difference of the paths. The light shines into a Michelson interferometer, a certain configuration of mirrors, one of which is moved by a motor. As this mirror moves, each wavelength of light in the beam is periodically blocked, transmitted by interferometer due to wave interference. Different wavelengths are modulated at different rates, so that each moment the beam coming out of the interferometer has a different spectrum. Computer processing is required to turn the raw data, which is light absorption for each mirror position, into the result of light absorption for each wavelength. The processing required a common algorithm called the Fourier transform. The raw data is sometimes called an interferogram.
FTIR is used for opaque or cloudy sample and microsample, tiny sample for forensic analysis. So if you want to know more, so let's proceed to the video.
The advantage and disadvantage of FTIR. FTIR technique offers several benefits which contribute to its popularity. High sample to its popularity. High sample throughput. The biggest advantage is highly sample throughput. In comparison to the time taken by dispersive instruments, the complete spectrum is scanned and displayed in a matter of seconds. The advantage of FTIR. FTIR instruments have distinct advantage over dispersive spectrometer. For example of the advantage of FTIR is simpler mechanical design, elimination of stray light and emission contributions, powerful data station, majority of molecules in the universe absorb mid-infrared light, making it a highly useful tool, universal technique, sensitive, fast and easy, relatively inexpensive and provide rich information, sensitive to molecules and lastly, sensitive to molecules, anything that contains chemical bonds. The disadvantage of FTIR are cannot detect atoms or monoatomic ions. Single atomic entities contain no chemical bonds. Cannot detect molecules comprised of two identical atoms symmetric as dinitrogen or oxygen. Aqueous solutions are very difficult to analyze. Water is a strong IR absorber. Complex mixtures such as sample give rise to complex spectra.
Assalamualaikum and hi everyone. Today I'm going to explain to you guys about applications in FTIR. So basically, FTIR is usually been used in food research, water quality analysis, identification of inorganic compounds and also organic compounds. Other than that, it can also be used for the satellite to probe space. So for more information, you guys can stay tuned on this video because I will insert more and more details about the applications. So yeah, just stay tuned. Bye. Okay, so hi. Now we are going to talk about the applications of FTIR. FTIR is usually being used in several things. For example, screening milk for abnormalities. First, to check if it has been contaminated with traces of cleaning fluids. It works by testing a sample of milk against a profile for normal milk. Natural raw milk has a particular infrared spectrum, a unique fingerprint. Using FTIR analysis, it is possible to program an analyzer to recognize the spectra, or fingerprint, representing pure raw milk. A warning is then given if there is a mismatch. This alerts the user to the need for further testing to determine the nature of the abnormality. The screening concept introduced a new and a convenient testing option for routine milk testing. Okay, so next, FTIR is also being used in forensic investigations. First, FTIR has the capacity to perform global assessment of components found in samples with no need of sample preparation, which is practically impossible with other routine analytical approaches. In forensic investigations, FTIR has been extensively utilized in multiple evidence-based cases at a crime scene, including question documents, banknotes, paints, fibers, hair, and gunshot residues. Alternatively, the feasibility of FTIR for chemically analyzing biological specimens has been demonstrated by other studies. Indeed, multiple macromolecules can be monitored simultaneously in an FTIR spectrum based on their unique infrared absorption frequencies. Okay, so lastly, FTIR is also being used on satellites. Why is it being used on satellites? Okay, so first, the chemical composition of the atmosphere is rapidly being modified by emissions. The consequences are far-reaching. A significant increase in the Earth's temperature and severe climatic change are real possibilities. To better understand and deal with these effects, better monitoring is required of the air's chemical composition and temperature. How can this be done? Each molecule possesses a fingerprint signature in the infrared spectrum. These fingerprints can be visualized with Fourier transform infrared spectroscopy, which is FTIR. Satellites equipped with ABB analyzers are providing data for a deeper understanding and an early warning of risk. And so, that is all from me for the applications of FTIR.
Assalamualaikum, and now I will tell you about the FTIR development. The first development of FTIR is the first low-cost FTIR machine is Perkin-Elmer was produced in 1957. Its wave number is 4,000 per centimeter to 660 per centimeter. The second type of development of FTIR is PDP-8 was produced in 1965. The third machine of FTIR is Digilab Pioneers, who produced in 1969. So now I will tell you about real life event of FTIR. The first is near infrared spectrophotometer. It's used to dedicate milk analysis to complement solution for dairy industry. The second is drug checking device, first in Canada, tested in Vancouver.
Alright, now are you guys already know about the type of FTIR instrument? I will tell you about that. The first picture is shown a common FTIR instrument that commonly used in laboratory. The second is Perkin-Elmer FTIR. For the third picture is Nicolette Magna FTIR. For the fourth picture is Thermo Fisher FTIR. And for the fifth picture is multi-gas FTIR. And the lastly, for the sixth picture is Carry 360 FTIR.
Dah. Weh, tak apa, jalan jangan terpotong. Dia dah pasal ni. Dia kena kat sana lah. Dia kena kat sana. Kenapa? Tangan dia kat kena. Ada getar lah kena. Mesti bila sekarang. I'm Nur Akila. I'm Rasika. Mula weh. Seperti pelakon tu. Zap. Aduh, kau lagi tangan.
만나면 반갑다고 뽀뽀 미소 한 방에 정신이 픽픽픽 전화긴 계속 링링링 여사친 이제 다 삐삐삐 정리하고 내게 어딘 닌닌 Everyday 기도해 365일 내 이름 대신 불러줘